Welcome to section 4.5, multiplying polynomials. So I'm going to give a basic definition for the distribution method for polynomials. If you remember, polynomials have terms, right? So terms are the things that are some separated by plus or minus signs. So let's say I have something like ax plus by plus, well, maybe let's do a minus c, right? We have some term polynomial. And it doesn't matter how many terms we have. Okay, I could go ahead, I'll do this ... to indicate there are a lot of terms. We don't know how many. If we have something in front of it, let's just say maybe b, or we could even do by. When we talk about distributing, if we have multiplication going on, okay, this is important, it needs to be multiplication, what we do is we then distribute this item on the outside to each of the terms. And so on, however many times are needed for each term gets an item. Just like if you think about it, if you're a parent and you have, some kids and they all want to go and do something, let's say, you would technically give them all the same amount of money for hanging out at the mall if you all dropped them off, right? You're not going to treat your children differently. You'll give them each $5, okay? So evenly distributed. You're giving everything the same exact item. All right, so let's take a look at example 1, do as indicated. Well, what is indicated? We have this 3 being multiplied to something inside of a parentheses. So the question is, how many times should I distribute that 3? Well, how many terms are inside the parentheses? We only have one term, so we'll just distribute it once. So that'll be 3 times 4xy squared. And then the only thing that we can actually multiply the 3 to is the 4. So we'll get 12xy squared. Let's take a look at the next one. Ooh, inside the parentheses now, instead of what this one before was called a monomial, so it was one term, we now have a binomial. There are 2 terms. We have that 8x squared, and then we have the negative 4y. So when we distribute what's outside of the parentheses that's being multiplied, we have to distribute it twice, once to the 8x squared and once to the negative 4y. So we'll go ahead and write it out. And I use a plus sign here. Negative 2x, negative 4y. And that will give me, well, we have the negative 2 times the x, times the 8, so that'll be negative 16. And then we have the x times the x squared. Well, if you recall, using rules of exponents, that's going to be x to the 3rd power. Keep the base and add the exponents. And then we have plus, and let's see. Negative 2 times negative 4, that'll be 8. And then x times y. No like terms on that, so it's just x, y. All right, once again done there. So now let's take a look at the last one. How many terms are in this? We have 1, 2, 3. It's 3, so it's a trinomial, which means we need to distribute that 3 1, 2, 3 times. So we'll get 3 times x plus that 3 times the negative xy plus the 3 times the 5y. Multiplying that up, we get 3x minus 3xy, and then plus, we have that 3 times the 5, so 15y. All right, there we go. So however many times you need to distribute, you distribute that many times, depending on the number of terms you have. Now let's take a look at something called FOIL. So if you'll notice, for the ones above, the item I was distributing had only one term. They were all single terms. It was 3 and negative 2x. That doesn't always happen. Sometimes we have something that has more than one term. So if we had something, let's say for example, x plus y times, let's say another x plus y. So these are called binomials because they each have 2 terms. What do we do for this? It's a little different than what we did previously. Well, one way to do it, and there are multiple ways, but one of the main, most famous ways for doing this is called FOIL. And that stands for each of the steps. So F stands for first. Let me go ahead and write this on the top. So first for F. What does that mean? Well, we're going to multiply the first 2 terms together first. So I'll go ahead and underline that in blue. So this is going to equal x times x. And then plus. Now what do we do? We're going to do the O, which stands for outside. So which ones are the outside terms? Well, that's going to be this x here, it's on the outside, right, and this y here. So that'll be x times y. Plus, now, what comes next in FOIL? I. So that'll be I for inside. So we'll look at the inside two, and that'll be these two. They're on the inside. Multiplying those two together, we'll get x times y. Plus, and what's the next one? It's L. L for last. So that'll be these two here, the y and the other y. Okay, and then you would go ahead and simplify as needed. So that would be x squared plus xy plus xy plus y squared, which actually also simplifies to x squared plus 2y. Sorry, 2xy plus y squared. Okay, so but that is the general method for when you have two binomials being multiplied together. FOIL is the easiest way to remember to not accidentally skip distributing a certain term. So let's go ahead and apply that here. Okay, so we have x plus 2 times 3x minus 5. So these are both binomials. They have two terms each. 1, 2, 3, 4. So let's go ahead and multiply. So f first. That's going to be x times 3x. Plus FOIL. So FO outside. X times negative 5. Inside. These two here. 2 times 3x. And last, 2 times the negative 5. And be careful, you need to remember to use that negative with the 5. Alright, so let's go ahead and write this down. We have 3x squared, remember we have those two x's, plus, well, actually that'll be a negative 5x plus 6x minus 10. And can we simplify? Are there any like terms? Yes, these two are like terms. Let's go ahead and simplify that. So that'll be 3x squared plus x minus 10. Not too bad. So let's go ahead and apply this method for FOIL in a slightly more complicated problem. So notice here we have a monomial being times to a binomial and another binomial. So there are two binomials. Now there are different ways to approach this problem. What I'm going to do is I'm going to first multiply out the binomials and then multiply in the monomial. So I'll drop down the 2x. I'll open up my parentheses because we're still going to be multiplying. And then I'll go ahead and multiply out the two binomials. So let's do FOIL. So first, we have x times 4x. Actually, let me change the color so it's still color coding for a bit. As we go along, I won't be color coding it, but for now, since it's being introduced, I'll color code it. 4x times x, sorry. So first outside, that's going to be 3 times x. Inside would be negative 1 times 4x. Plus, and last, negative 1 times 3. Okay, let's go ahead and simplify what's in the parentheses. So we have 4x squared plus 3x minus 4 from the yellow, and then minus 3 from the blue. Can we simplify? We can, and usually with binomial multiplication, when you're doing FOIL, usually there are two that do end up simplifying together. So that'll be 2x times 4x squared minus x minus 3. Then we'll go ahead. Now we have a monomial timesing the binomial. So let's go ahead and distribute in that 2x to each of the terms. There are 3 terms. And then we get 2x times the 4x squared minus 2x times the x minus 2x times the 3. Okay, so careful, you need to make sure that you have your negatives with the problems. Okay? So do not forget the negatives. Or, better yet said, remember the negatives. Okay, so remember to bring those down. Negatives are often what gives students problems on their work. Alright, so what do we have? We have 8x cubed minus 2x squared minus 6x. And we are done. No like terms, nothing else to multiply. So now we have something called the difference of two squares. If you see when you have two binomials, okay, so this is important, we're talking about two binomials. Let's say you have one term, and then it's an addition, so x plus y, and then the other one is exactly the same for the first term and the second term. Okay, so exactly the same number or value, but the only difference is the signs. Okay, so the only difference we're talking about here is the sign. Then what's going to happen is you can have a shortcut. The answer is going to be the first term squared minus the second term squared. Alrighty, let me go ahead and fill that out. Okay, so x squared minus y squared. How do we know this? So let's go ahead and prove it real quick. So if I was to do FOIL, this is my little proof here, I would be multiplying the first two together, so that'll be x squared. And then I'd do, so first outside, so x times y. Inside, x times x, so we get negative xy. And then last, I have y times y, so that would be positive y squared. Oh, sorry, that'd be a negative y squared, excuse me. And then when I go ahead and I simplify, you'll notice that the inside terms, they're going to cancel because one's a positive version and the other one is a negative version. These two cancel out, and we're only left with the x squared minus the y squared. Okay, so if you have, and these guys are called conjugates. If you have conjugates, so they have the exact same first term and exact same last term, but the only difference is the signs. If you have conjugates, then what you have is the difference of two squares. Just square the first term, subtract, square the last term. So let's go ahead and try that on this problem. So do as indicated. Well, are these two conjugates? They are. We have y and a y. Then we have a 5 and a 5. The only difference is the plus and the minus. So let's go ahead. Let's ignore the fact. Let's pretend that we hadn't noticed they were conjugates. And let's see if, when we do FOIL, the inside terms actually do cancel out. So doing FOIL, the first terms tied together, that'll be y squared. And then, so we have first to outside, 5y. Inside, negative 5 times y. And last, negative 5 times 5, so that'll be negative 25. That'll be y squared. Ooh, and the 5y values cancel out. The middle terms did cancel out. Minus 25. Now, is that the same as if we had followed the formula for difference of squares? Let's see. Well, the formula for difference of squares is to take the first term and square it. So what was my first term? My first term was y. Well, if I square y, yeah, I get y squared, so that checks out. And then it was to take the last term and square it. Well, that's 5. If I square 5, what do I get? 25. Oh, okay, so the method does work. So instead of having to do this inside step here, if I'd noticed they were conjugates before, I could have just gone directly to that other step. So it's a nice shortcut. Now let's take a look at B. Okay, so looking at these two binomials we have being multiplied to a monomial, what do we notice? Ooh, they are conjugates. So instead of doing the whole FOIL thing, I can just go ahead and do the difference of squares. So let's go ahead. I'm going to bring down that 4x. We're not multiplying it yet. Let's focus on the two binomials. Their difference of squares, so we'll take the first term and square it. So that'll be 2x squared. Minus, and I'll take the last term and square it. So 3 squared. And what do I get? I have 4x times 4x squared minus 9. That was pretty quick. Last thing to do is we're going to multiply in that binomial, the monomial into the binomial. So we'll go ahead, multiply that in only 2 times. And we have, so 4x times the 4x squared minus 4x times that 9. We get 16x cubed minus, let's see, that's going to be 36x. And there we go.